Okay, lecture 4.2. All right, week 4 Wednesday. Here we go. We are going to take a small departure from. So we've been following along in the textbook Think Python, and a lot of the kind of material has been coming from there. Think Python focuses primarily on base Python, which is excellent and necessary. However, to do some proper, I guess, data science type stuff, it's very useful to have NumPy. NumPy introduces a data structure called the Numpy Array, which is that's my thing not working. Okay, there we go. The Numpy Array, which will be important as far as computing speed and things like that go. So you have to import NumPy whenever you're going to use it, and you can just write import NumPy, but the trend and this is important is you do import NumPy as NP. Okay, now technically you can write any word you want here. Okay, like any kind of variable name, you're technically allowed to write import NumPy as num or whatever you want to do, but it's going to confuse people. Okay, because this is the convention that everybody follows. Everybody writes import NumPy as NP, and then whenever you need to refer to a function within the NumPy module, you're going to write np dot nd array or whatever it is, and people are accustomed to seeing that. And if you don't do that, it's going to make it difficult for other people to read your code. So make sure you always do import NumPy as NP. Okay, so you can just do this import NumPy as NP, and if you want to check what version of NumPy you have, you can do np dot $version. So this is __ version. We often call this double under, and I think, let's see. The latest version is 1.22 was just released, but yeah, I have one slightly before that, 1.21, and that's what we have. All right, and so the key data structure that NumPy introduces to Python, which doesn't exist in base Python, are NumPy arrays. Okay, NumPy arrays are mutable, and they in some ways they act kind of like lists, but different from lists is that the NumPy array is only allowed to contain one type of data. All the elements in the NumPy array have to be of the same data type. So you can have a NumPy array for doubles. You can have a NumPy array for integers. Those are probably going to be your most common NumPy arrays. Or you can have some different kind, like for characters or Boolean values, but in general, the NumPy array, everything has to be of the same type, which is different from the list. In the list, you can mix strings and numbers and things like that. Okay, so in that way, it's kind of like the atomic vector in R, and a structure that's analogous to the atomic vector in R just did not exist in base Python. Okay, so you can create the NumPy array directly using np.array, np.array. All right, and then another way is you can create a list with square brackets, and then once you take that list, you just put it straight into np.array. All right, so here is one way to. I'm sorry, this is not an or. This is kind of direct creation of the NumPy array. Is you'll do np.array, and then you have the parentheses, and inside there I've got a list. All right, And this is the way it looks. It's going to say array 1, 2, 3 inside the array. Okay. When you print out an array, this is how it appears. Okay. It looks this output looks kind of like a list. When you print out a list, how is it different from the Numpy array? What's the key kind of distinguishing difference as far as it gets printed out? Okay, the difference here is that when it gets printed out, there's no commas, right? There's no commas in an array. So when you look at an array, there's no commas between the values. Whereas if it were a list, you have commas, right? So here's a list, and this one's an array. Okay, so if you look at the object directly, it says array, and then you've got this thing. But when you print it, it looks like this. Okay, so these are just some subtle distinctions. Okay, when you ask what's the type is going to be numpy.nd array. Numpy.nd array is going to be its type. All right, if you do mix data types within an array, the array will get upcast. This is kind of like the same idea of coercion in R. In R, it will coerce values to all the values to be of the same type. In NumPy, we call it upcasting, and it's going to upcast values from the restrictive type to the less restrictive type. All right, so here I am mixing some integers 1 and 2 with a float 3.0 and some logical Boolean values, false and true. Okay, 3.0 is a float. That's going to be the least restrictive type, and so it's going to upcast, or you can think of it as coerce, everything else to floats. And so we can see that happens because now we have a 1 dot, a 2 dot, a 0 dot, and a 1 dot to indicate, the dots indicate that these are floating point numbers. Okay. If I put 3 in strings, in quotes here, making it a string, then now this is the least restrictive type, and it's going to upcast everything to also be strings, type strings. And you can see that's what happens. True gets put in quotes, false gets put in quotes. The integers 1 and 2 get put into quotes. Arrays also, you can have 2-dimensional, 3-dimensional, higher dimensional arrays. Okay, you can create a higher dimensional array, and that's going to behave a lot like a matrix. And so the way we would create, we can create an array, or a matrix, or a higher dimensional array in NumPy is to provide it a list of lists. Okay, so here I've got outer bracket. I have a list of 2 things, and the 2 elements inside are each 3 elements long. Okay, so this is going to be 2 rows and 3 columns. I've got a list 1, 2, 3, and then the next element is another list 4, 5, 6. And so the resulting matrix, or the resulting array, is 2 by 3, and we can see that it's a two-dimensional array because it starts off with 2 opening square brackets. Okay, so this is the way a 2-dimensional array gets printed. You have an opening square bracket for the higher dimension, and then another opening square bracket for the row. Okay, and then you have another array for the next row, and then the closing to kind of close off the matrix, or the 2-dimensional array. There's a lot of kind of information provided in just the way something gets printed out in Python. Okay, so when you print out the array, seeing these two opening square brackets informs you right away that this is a two-dimensional array. If when you create this array, we had two lists inside here. Each list had 3 elements in it. If for whatever reason you create a list with lists with lengths that do not match, right? So here I've got a length 2 list here. The first element in the list is a list of length 3, 1, 2, 3. And the second element in the list is a list of length 2, 4, and 5. And when I say make an array out of this, Python does it, okay? And it says it's an array where you've got 2 list elements in it. And then we also get this warning, okay? It says visible deprecation warning. It says you created an ND array with ragged nest sequences, which is a lister tuple of lister tuples with different lengths or shapes is deprecated, okay? And if you meant to do this, you must specify data type equals object when creating this thing. It just says, I think you made a mistake, okay? And you can kind of force it, but it's not so useful even to begin with. So why bother? All right, before I keep going, let's, oh, the viewing quiz is closed until 10 a.m. Thank you for pointing that out. Seem to be, let's see, okay, let me edit this. Okay, so change this. So now open. Okay, so now the viewing quiz should be open. And the very first view quiz answer for today is the letter D. D as in dog. D as in dog is your first view quiz answer for today. D as in dog. Okay. You can also make some other arrays very quickly, especially if you just if you know the dimensions, but you don't really care what values go inside. So if you just need kind of like an array of a certain shape or certain dimension, just as a place to store values later, you can do something like this: np.zeros, and then you would do 5. Okay, and this will be kind of like as in R, you can repeat the value 0 5 times or something. So you can just do np.zeros 5, and it's going to create an array of length 5. Okay, and the default when you call zeros is that it's going to be floating type. Okay, floating point numbers. These are all 0 point there. If you want integer 0 rather than floating point 0, you can do np.zeros 5, and then you can say data type D type is ints. Okay, and you can specify integers instead, and you'll get this. You can also specify more than just the length. You can give it a tuple of kind of your dimensions. So this will create an array that is 2 rows, 4 columns. So you're going to do np.zeros, and then you'll give it a tuple that says 2, 4, and this will give you a 2 by 4 array of zeros. Okay, and then here is I'm creating a 2 by 3 by 4 array. All right, so what is this? Okay, so the dimension order is, so this is a 3-dimensional array. All right, and you can think of 2 sheets or 2 layers each layer is 3 rows, 4 columns, right? So 2 layers of 3 rows, 4 columns. So you've got kind of layers or sheets, rows and columns. And with NP zeros, it just fills everything out with zeros. And again, default is floating point numbers. You can even create higher dimensional. So this would be a 4-dimensional array, some kind of hypercube, I guess. And so this, you can think of this as an array of kind of 2 blocks. Each block is 3 sheets, and each sheet is 4 rows and 5 columns, right? So you got 4 by 5, you've got 3 of those layers. That's going to create a block, and then you've got 2 of those blocks, and that's going to be a 4-dimensional array, and it keeps going, right? So you can have arrays of some arbitrary number of dimensions, and that's kind of what powers things like TensorFlow. We call these these arrays tensors and things like that, and you've got kind of these mathematical processing units and stuff to do that. All right, there's going in parallel, not in parallel, but just like np.zeros, there's a function called np.ones, and then there's np.full. Okay, np.ones will, instead of putting 0, you put in, it's going to insert ones, and it works exactly the same way as np.zeros. It's just the default value is 1 rather than 0. And then np.full works in the same way, except you specify over here what value that's going to get repeated. So if you wanted to create an array where, instead of 0 or 1, you wanted to put in some other arbitrary value, you can do that. All right, and that's np.full. And these are just quick ways to create some kind of array in Python of a certain dimension and shape, and so it's very useful in that regard. You can also generate random numbers. This is often something that we want to do. The NumPy uses the Mersenne twister, which is the same random number algorithm used in R. And a lot of other computing languages use the same Mersenne twister. The details of which are, I'm not going to get into beyond the scope of the course and complicated. And to be honest, I don't know if I even fully understand the details of it, but that's going to be the random number generator that we use. All of the random number generator functions start with np.random.something, okay? And so if you want to be able to reproduce your random results, you can set a seed. So you can do np.random.seed. You put in some kind of arbitrary number. So here I'm just going to put in the number 1. And now I can just ask for random values on the interval 0 to 1. And so it's going to be np.random.random 5. I want 5 random values between 0 and 1. And you can see all of these are basically decimal values written in scientific notation. So this would be 0.417, 0.723. This one would be 0.000114 and 0.302 and 0.146 and et cetera, et cetera. Okay. If you so this is kind of your random uniform values from 0 to 1. Random uniform is just random.random, np.random.random. If you want random normal values, so this will be values from the standard normal. So mean 0, standard deviation 1. 95% of values will be between 2 and -2. 99.7 will be between 3 and -3. You can do np.random.randn. Randn will be random normal, standard normal values. And so here I'm going to ask for 5 values from the standard normal distribution, and it's going to return a Numpy array. And I got, you know, negative 1.1, negative 1.65, negative 2.36, et cetera, et cetera. Okay. If you want to specify, a certain certain mean and certain standard deviation, you can also do that, right? So here I'm going to say np.random.normal. So random.normal will generate values from the normal distribution, and I'm specifying mean of 10, standard deviation 3, and over here I'm saying how many values I want. And here I'm saying I want an array that's 2 by 4. I want 8 values, 2 rows, 4 columns. Okay, and I could have put in this tuple 2, 4 into any of these, and it would have generated an array of that particular dimension. Here I just, you know, much in the same way that np.zeros generates an array of length 5 when I do this, and np.zeros would have generated an array that's 2 by 4 here. You know, you can put in any kind of sized dimension here, and it will generate random values of that, arranged in an array of that kind of the dimensions that you specify. Another very useful one would be np.random.randint, and this will generate random integers. And so here we can say starting from 0 up to 10, but this is exclusive. So this will generate digits from 0 to 9, 0, 0, 10. So that will generate digits from 0 to 9. And if here we say 20 values. And so it gives me an array of 20 integers, 0 through 9, 20 single digit values here. So for example, if I wanted to simulate dice rolls, which will be any number from 1 through 6, I can do that. And I can just say 1, 7, and I want 50 of these things. Okay, I know it feels a little bit weird. Why not just 6? Why not just 9? Why do I have to go to 10? Why do I have to go to 7? And that's just kind of a little bit of a holdover from a lot of Python's other functions. So the way, if you think of the way range works, if you think about, you know, a lot of these kind of sequence functions in Python works, they're all, the starting number is inclusive and the ending number is exclusive. And that's just kind of the general pattern for all of these things. And so they're just kind of staying with that. You just kind of remember that, okay? I think I'm referencing the older documentation here, but you can always look up the manual, okay? So random sampling and numpy.random. I should probably update the link that I have in our notes here. Okay, oh, we'll do that. But yeah, if you just do numpy.random, you'll get kind of all of the stuff that you can use. Okay, and actually, all right, we can make sequences. So much kind of like creating a range object in NumPy. All right, you can do NumPy, or I'm sorry, creating a range object in Python, you can create a range array, a ranged array in NumPy. And this is going to be NumPy A range, okay, for array range. And it works with the same arguments, start, stop, and step size, where the start is inclusive, the stop is exclusive, and then you can specify the step size if you want. So you can just do So the range object in regular Python would be range 0, 10, 2, and that would generate the even digits from 0 to 10 exclusive, 0, 2, 4, 6, 8. If we do the same thing in NumPy, we get pretty much the same thing, 0, 2, 4, 6, 8, except this is now a NumPy array. Okay. You could kind of manually create the range and put the range object inside numpy.array, and you'll get the exact same thing. But at that point, you might as well just do numpy.arange, right? So here is NumPy array being applied to a range object, but I would just recommend doing this. Okay, you want to count by fives, you can do 0, 100, and it's going to go 5, 10, 15, all the way up to 95. And then just like before, you can just give it some integer value, and numpy.arange 20, and it's going to start at 0, go up to 19, because the start is inclusive and the endpoint is exclusive. So it's going to go 0 through 19, numpy.arange. Other things that are useful is the linear spaced array. All right, and so this is useful if you want to create an array of a certain length, but you don't actually know what the step size is going to be. Linearly spaced means all the values will be equally spaced out. Okay, and again, the key difference here is that the stop in linspace is going to be inclusive. All right, so here I'm going to say linspace 0, 100. And if I want 11 values total, then everything will be spaced out 10. Okay, then I'll start off at 0 and go 10, 20, 30, 40, 50, all the way up to 100. We're going to have a total of 11 values. All right, and so this is going to be linspace 0, 100, 11. All right, and again, the default is to create floating point numbers. Now, if you forget that to include kind of like the 0 or something, and you do 0, 100, 10, well, it's going to space those 10 values out evenly. And so you're going to get 0, 11.1, 22.2, 33.3, so on and so forth. And this is what it looks like there. Okay. You can specify the endpoint to be false. All right. And it's kind of like doing linspace 0, 100, 11, and then throwing away the last number. Okay. Because when you do endpoint equals false, it's not going to include this. And we're going to have, it's going to go from 0 through 90 spaced out by 10. But it's a little bit, it feels, sometimes the values you get can feel a little bit confusing. And again, I think it's easier to think of this as doing 0, 100, and then using the full size. And then when you do endpoint equals false, it just throws away the last one. So if I do 0, 109, it's going to space everything out. And the last number it encounters is going to be 88.88, right? So, how do you figure this? The number I specified here is 100. Well, basically, I figured out the spacing based on 10, and then it threw away that last number. After you create an array, you can always ask for certain attributes. You can ask for the number of dimensions in the array. So here I've created a 2-dimensional array, np.ones, 3 by 4. And I can say, how many dimensions is this array? And it's going to say the number of dimensions is 2. All right. What is the shape? What are the dimensions? The dimensions themselves are given by the shape. The shape's going to be this tuple, and it's going to say it's a 3 by 4 array. Okay, 3 rows, 4 columns. It returns a tuple with the actual dimensions, or we call this the shape of the array. And then what is the data type that is stored inside here? And it tells us that we've got floating point numbers. And more specifically, these are 64-bit floating point numbers. 64-bit floating point numbers means we use 64 bits in memory to store the number. And if you were trying to code for some different system where maybe memory was more limited or something, you could use smaller numbers, float 32-bit floating point numbers, et cetera, et cetera. All right, I think you could even use 80-bit floating. I think that's the long. I don't remember. I don't remember all of the details. In general, 64-bit floating point numbers is the most common type of floating point number that we use. And if you had to program for a different system with limited memory, Python probably might not be your language of choice. But anyway, this is what we've got. Let me go ahead and give you your second view quiz answer for today. Today's second view quiz answer is the letter D. D as in dog. D as in dog. D as in dog. Or dimensions is your second view quiz answer. All right. So here is, let's create a range object in NumPy. If you ask, what are the dimensions of this thing? It's a one-dimensional object, okay? It's kind of like a one-dimensional vector. We ask, what is the shape? What's the shape of this thing? The shape is a one-dimensional array, okay? And it's going to just say it's got a length of 12. Okay, this is a one-dimensional array. There's no second dimension, but to kind of indicate, right? And it returns a tuple. It returns a tuple. And so how do we tell? How does Python let us know that this is a tuple of length 1? It gives us 12 comma. It's a tuple of length 1. Okay, one-dimensional array. That's what we get. Tuple of length 1. You can take an array and reshape it. All right, so you can do an existing array, and then you can give it a new shape. So for example, we're going to start off with J here. This is one-dimensional, right? And let's say we want to reshape it into an array that's 3 by 4, a 3 by 4 array here. Okay, so this is going to be np numpy.reshape. We take this thing and we just reshape it into a 3 by 4 array, right? And then array.t is going to transpose whatever array that you have. So and when you do a reshape or something like that, it leaves the original array unaffected. Okay, so when you call reshape on an array, it leaves the original array unaffected. So here is you can also, so when you call numpy reshape on J, it's going to leave J unaffected. It will return a new thing. You can call j.reshape as well. Okay, so you can take the array and call .reshape, and you provide it just the dimensions right there. So notice the difference between what we have here. We've got numpy.reshape. We give it the name of the vector or name of the array and the dimensions we want. You can also take the array and do .reshape and provide it the dimensions you want. Okay, and that will work. But again, the original array J is left unchanged there. Okay, here here's the reshaped array K, and I can do k.t. T is going to transpose this, and so go 0, 1, 2, 3, 4, 5, 6. So this is 3 by 4, and this will transpose it to 4 by 3. Will it throw an error for non-conformable arrays? Yeah, when we do like multiplication, it will, and I'll show you that in a moment. Okay. Again, K, when you call k.t, it doesn't actually affect the original K. It just returns kind of a transposed copy of K. So you can kind of all of these things, when you create them, the returned object is a, what do you mean? What about during reshaping? Sorry, I don't know if I, so here I've got k.t. Oh, if I try to reshape it, like if I said here's a length 12 and I want to make a, you know, a 3x3 or something like that, or a 5x2, 5x3, sure. Yeah, we can see what happens here. Let's try that out. But anyway, I want to show you that you can take an object and you can kind of keep linking methods as long as these methods exist. So for example, we can start off with an A range, and then I can do dot reshape, and that's going to reshape the range object. And then after I reshape it, I can do dot t, which will transpose it. And that's fine. I don't have to kind of create these intermediary objects and say, take this intermediary object and then transpose it. You can just kind of continue to link all of these methods together. So A range to create the range, dot reshape to reshape it, dot t to transpose it. And we can set that all equal to L. And here's L. L is going to end up being 4x3 filled out by columns here. Okay. Here, let me, I think, let me see if I have an example where I've done this. All right. Sometimes you will see in Python, you'll see this -1 business. -1 basically means I've given you basically the information you need. Python, figure out the rest on the own, okay? Or NumPy, figure it out. So here is J. It's a length 12 array. And what I'm going to say is I'm going to reshape it, and I want to reshape it so that it has 3 rows, but I can't be bothered to figure out how many columns this is supposed to be, okay? I know it's supposed to have 3 rows, and yeah, so NumPy is going to figure it out. It's going to say, oh, there's 12 items. If you want 3 rows, then that means it's got to be 4 columns, okay? It's got to be 4 columns. But here, -1 just says, I, the human, I don't want to be bothered with figuring out what number to put in here. So just make sure it has 3 rows, however many columns you need to make that happen, just do it. That's what the -1 is, okay? Similarly, we can say -1, 4, and this will say, all right, I just want 4 columns. You figure out how many rows you need, okay? Here I can do 2, -1, 2. And this will say I want 2 sheets, some arbitrary number of rows, and I want 2 columns. And again, Python's going to figure out how many, the missing dimension, okay? Now you can't have more than, so if I had -1, -1, then it's going to get angry because it's going to say, well, you gave me too many unknowns. So you can only kind of use one unknown. Only one column can be unknown using the -1. Okay, so I guess let me show you reshaping into something. All right, so import np. So we'll do x is equal np 12. All right, so here's x. All right, and then so let's do x.reshape. All right, so let's try 5x3, okay? And here, when you try to reshape it into something that that's not going to work, we get an error here, okay? If I try to do x.reshape, say 5, -1, all right, it also says it can't do it, okay, because I got 12, so it's not going to let me do it. I can shape it into 6, -1, and that works, right? With 12, I can do 6 rows, and it figures out how many columns we need, but it won't let me do it for 5 or something like that. So these are the errors you get. You get a value error. That's the error that you get when you try to reshape it into something that that doesn't work. Okay, here's a one-dimensional array. Okay, and again, when we ask for the shape, we get a tuple of length 1. And if I say I want to transpose this, okay, well, there's nothing really to transpose, right? It's one-dimensional, so there's no axis to kind of transpose against. So it remains a one-dimensional array. Okay, the transpose of a one-dimensional array remains one-dimensional. There's nothing to really do. And if you ask, hey, what is the shape of y dot transpose? So y dot transpose dot shape is still a tuple of length 1 of 12. Okay, so if you want to transpose kind of a row into a column, you need to specify to Python that this is indeed a row vector. So so then you have to reshape y from being one-dimensional into a two-dimensional, where one of the things is dimension 1. So you can reshape y into 1, 12, and now this is a two-dimensional array. We can ask, what's the shape? This is 1 row, 12 columns. Now I can transpose this. Z dot transpose is going to be 12 rows, 1 column. We are transposing this dimension, the shape here, the values in this in the shape 1, 12. If we ask what is the shape of Z dot transpose is going to be 12 by 1. Okay, so Z is 1 by 12. Z dot transpose is 12 by 1. So you can't just take a one-dimensional thing and transpose it. If you want to take a row and turn it into a column, you need to say, well, this thing actually exists in 2 dimensions. Okay, you can subset and slice arrays, and I got to kind of pick things up a little bit. So subsetting and slicing is very similar to lists. So you can take some array and say, I want the index 4 element. Okay, I want index elements 4 through 6, and it will return basically the elements there, 4th column to 6th comma type of thing. You can also slice with a second colon. So you can write something like this, 1:8:3. And what this will do is basically start, stop, and step. Start, stop, step. So for example, I can create an A range from 0 through 99. And I can say start at 0, go up through 100, step size is 2. And now we get all of the even numbers here. Okay, and this I could have just done A range 0, 102 and gotten the same results, but you can also kind of just slice it. You can slice it to just whichever values that you want as well. So if you want to slice in or subset in higher dimensions, you can do that. So so here is my array Z. Z is a 3 by 4 matrix. And I can say I want the element in row index 1, column index 2. So remember, Python is 0 indexed. So row index 1 is actually the second row or the middle row. And column index 2 is basically the third column. And so that's going to be element 6, the 6th element there. Okay. And if you ask, what is this? This is not a Numpy array. When you subset this to just one element, it will return the one element itself. It's going to be an integer, the integer. It's not a Numpy array with one value in it. It's the integer 6 itself. Okay, but you can also slice entire rows and portions. So here we're going to say I want to slice Z. So here's element Z, array Z, and we can say we want to slice rows 0 through 2 and columns 0 through 2. Okay, so when you slice 0 through 2, it's going to get the first two columns and the first two rows. So we're going to get this kind of this top left corner here, 0, 1, 4, 5. And that's what we get, 0, 1, 4, 5. Or you can say I want row index 2. Row index 2 gives me this entire row. And then here we have comma space colon, meaning the entire row. So to kind of say I want everything in the all of the columns, I guess, give me row index 2, all of the columns, we would do comma space colon, or just comma colon to get everything there. And notice these things return arrays because it's not just one value, it returns the entire array. What's the shape? The shape of this thing is one-dimensional, length 4. Okay. And then similarly, if you can say I want just the second column, okay. I want this, I'm sorry, the column index 2, you can do z colon, all the rows, comma 2, right? And this returns the column 2, 6, 10. And again, this is one-dimensional. So here it's a column 2, 6, 10, but when you slice it down to just that single column, it becomes a one-dimensional thing. It's not 3 rows, 1 column. It's not this, it's an array of length 3, a one-dimensional array of length 3. It's not the column 3 rows, 2, 6, 10 down the column, 3 by 1. It's an array of length 3. Okay. One thing is that NumPy slices are view objects, meaning they are dynamic and they automatically update if the original array is updated. Okay, so let me remember, NumPy arrays are also mutable. So for example, okay, here is my array Z, and I'm going to slice it to be this top left corner. Okay, so we're going to subset Z to Z, basically 0, 2, or just 2, 2. And that's going to give me this top left corner, 0, 1, 4, 5. And indeed, when I say, what is the subset of Z, I get 0, 1, 4, 5. Now, look what happens. I'm going to assign the value 99 to the 0, 0 element. Okay, I'm going to replace the index 0, 0 element, the top left element, into 99. And so when I ask, what is the subset? Okay, the subset is a view object, meaning it updates dynamically, right? It is giving us a view of what is happening to Z. This is not a copy, okay? It's not a copy of this, meaning that when I change Z, I also change the element here, okay? Because I didn't assign it to Z sub, right? I'm assigning it directly to Z here, and it changes it there, changes it in the subset there, right? So it's kind of you're viewing a subset here, right? And then and this got printed out funny, but again, if you take a look at Z itself, we can see that the top left element is 99, and here we're getting a glimpse of that right here. All right, here we're going to create an entirely new object, okay? So here Z gets redefined to be an entirely new object. This is different. So here I modified this element to be 0. Here I'm calling for the creation of an entirely new array. Z np.arange.reshape. And so now we have this, and Z sub, this subset, which is the view object, is still pointing back to this old array back here that we created. So this object exists somewhere in memory. It no longer has a name, okay, because we created a new object, and we took that name Z and we're pointing it to this object. So the original matrix, or the original array that we created, no longer has a name, and but it still exists in memory, and this subset thing is pointing to it. Okay, I'm running out of time, but if you want to do copies, you can do array.copy. All right, you can do array.copy, and we can see how that's going to affect. And so this is here I'm creating a copy of the subset. So this is going to look at 0, 1, 5, 6, and here I'm going to change the top element of Z to be 55, top left element to be 55, but it doesn't affect the copy because it's a copy. Okay, so you have all of this stuff, and yeah, I think you can look at the remaining bits. There's only one page left here to kind of see. But we'll go ahead and end here. Oh, I need to give you your last view quiz answer. Today's last view quiz answer is A as an apple. A as an apple. That is the last view quiz answer for today. A as an apple. Okay, that's it. That will be serve as our very, very, very brief introduction to NumPy. We will look at some more NumPy on Friday, and we will see you guys then. Don't forget to do your data camp homework as well. So that that's been up for a little while, and a lot of you guys have done it, but some of you still have not. So please just remember to still do that. Okay, have a good day. We'll see you guys on Friday.